All right, let's review some derivative rules as we review Calculus 1 here. First, let's remember what the definition of the derivative is. So if we have the derivative of dx of f of x, so this is the limit as h goes to 0 of f of x plus h minus f of x all over h. So this is just slope, right? Because the derivative basically is the rate of change. It's the instantaneous rate of change. And as this difference from x to x plus h, which is h, as that becomes 0, there's no difference, then we end up with the instantaneous rate of change, which is the derivative. Now, we can do that. We should be able to do this for lots of things like f of x, lots of functions like f of x equals x squared. And we should be able to find the limit as x goes to 0, h goes to 0. H goes to 0 of x plus h squared minus x squared all over h. And as we do that, so let's go ahead just for kicks. Let's go and work this one out. X squared plus 2xh plus h squared. And minus x squared all over h. And as we clean this up here, I think we got some h squared or x squareds that are going to go away there. Yep, lost my h there. And that brings us down to the limit as h goes to 0. And we're going to divide an h out of both of these, so that's 2x plus h. And as h goes to 0, then this is going to go away, and we're left with 2x. And we know that this is the derivative of f, if f is x squared. Okay, so we got that. That's the long process, and we found some patterns. We see that, hey, look, that 2, that exponent just drops down. And it becomes 2 times x to the first power, right? And that's our power rule, all right? So these rules are just the result of some observations that we can prove to ourselves from that. So keep that in mind. It all goes back to that limit definition. So here we go. We got this rule, power rule. If we have a power, we can drop the exponent and subtract 1, right? Remember that? So what if we have some things like this? Well, first thing we want to rewrite this. Radicals are fractional exponents. And if we have powers down below, that's going to be x to the negative 5th. And now that we have everything written as in powers, we can go ahead and take the derivative, drop that 5. 5 times 3 is 15, x to the 4th, subtract 1. Drop that 1/2 down, subtract 1, and that becomes negative 1/2. Drop that negative 5 down, and we have minus 5. Subtract 1 from negative 5, and we get negative 6. And we should go ahead and rewrite this with positive exponents. And so this is minus 1 over 2. X, the 1/2 goes to the bottom, so the square root of x. And this is minus x to the 6 is going downstairs. The 5 stays upstairs. X to the 6th. Okay. All right. Let's go to the product rule. We'll save the chain rule there. Let's go to the product rule here. Okay. So the product rule says if we have two things being multiplied and we want to take the derivative, we take the derivative of the first times the second plus the first times the derivative of the second. So we got this sum. One of them we take the derivative of the first one. One of them we take the derivative of the second one. Okay. So here we have u and v. So the derivative of f is going to be derivative of the first. Now, little useful tool here is this. Let's move this down there. A little side note, the derivative of the square root of x, which is the derivative of x to the 1/2, like we kind of just saw, well, it's going to come out to be 1 over 2 square root of x. Okay? So that 1/2 drops down, that's your 1 over 2, and that x goes downstairs. That's kind of a useful one just to kind of have memorized, all right? So let's go u prime times v plus u times v prime. Okay? So u prime would be 1 over 2 square root of x, and times v, which would be 2x cubed minus x, plus u, which is the square root of x, times the derivative of v. Derivative of v is 6x squared minus 1. And we can clean this up a little bit. We don't need to get too crazy. This is not an application. We don't have any reason to really do a lot of simplifying. If we distribute this square root of x here, we'll end up with, I guess, 6x to the, we could say 3/2 minus the square root of x. All right. So you might ask yourself and kind of wrestle with the question, all right, well, how far should we simplify it? Well, actually, any of these are good on the AP test or on our test, even if you left it like this, that's acceptable. So, all right, not much you can do. This is not going to get much prettier. The quotient rule, all right, the quotient rule, we're got u divided by v prime. Well, we can take the derivative of the first times the second minus now the first times the derivative of the second. So it looks a lot like the product rule up here, right? Especially if we write the product rule this way. Sometimes the product rule is written differently, but u prime v minus uv prime all over the bottom squared, all right? So let's try that out. So here we have y prime sine over cosine. Well, we've got the derivative of u, which is the top. So this is u, this is v. So the derivative of sine is cosine of x times the bottom, which is cosine of x, minus the top, which is sine of x, times the derivative of the bottom. Derivative of cosine is negative sine of x, all over cosine squared, the bottom squared, which gives us cosine squared x plus sine squared x all over cosine squared x. Okay? And that's just 1 over cosine squared. Do you remember what 1 over cosine is worth? If you forgot those, you might want to work on your identities there. 1 over cosine is secant. So this is secant squared of x. So there's y prime. Now, what do you notice here? Well, sine over cosine, what's another way to write sine over cosine? Isn't that tangent of x? Okay. And so the derivative of tan x is secant squared. Okay? That's what we kind of just proved. All right. How about the chain rule? Well, chain rule, we have two things. The dy dx is equals dy du times du dx. Okay? In other words, if we have the derivative of a composite function, we take the derivative of the inside times the derivative of the outside as a function of the inside. Okay, what does that mean? Well, here we go. We got y prime. Okay. The derivative of the natural log of x is 1 over x. So this is g of x. And sine would be f of x. Okay. So the natural log is in the sine. Okay. All right. So y prime, here we go. Y prime, the derivative of g of x, the inside, is 1 over x. So the derivative of the inside times the derivative of the outside. What's the derivative of sine? Well, that's cosine. So the derivative of sine is cosine. That's the outside. And we're going to go ahead and leave natural log of x in there. So this is the inside derivative right here, and this is the outside. Okay? That's the idea there. Okay? Sometimes we have x's and y's all mixed up like this, right? Well, we remember when we look at this here, we've got y. Y is a function of x. Now, if you try to solve this for y, it's going to be a mess. Sometimes you might be able to do it, but like, look at this one. I don't think you could solve this for y. I don't know where to start. It would be just a mess. Okay? So we don't need to solve this because we're looking for dy dx. So we're going to use d dx as an operator. All right, so let's take our function x squared y, our equation I should say. It's not written as a function right now. But we're going to keep in mind that y is a function of x. Okay, so we're going to use the operator d dx. So we'll take the derivative of this side, and we'll take the derivative of this side. Okay, so the derivative here, we're going to take the derivative of the parts separately. Here we're going to need to use the product rule. So we got the derivative of the first is 2x times the second, y, plus the first, x squared, times the derivative of y. What is the derivative of y? Well, that's dy dx. Because I don't know what y is. I just know that I need to find the derivative of it. Plus, now the 3 times y to the fourth, so this is the chain rule now. So y is a function. I don't exactly know what it is, but it's a function of x. So I need to take the derivative of the inside. The inside is y. So the derivative of the inside is dy dx times the derivative of this thing as a whole. So now I'm going to treat y kind of like x. I'm going to drop that 4 down. 4 times 3 is 12. 12. Y, subtract 1 from the power, and we get 3. Okay? Then we're going to take the derivative here. Okay, so we're going to use the chain rule again, because this is e to the y, and I don't exactly know what y is. Y is some function of x. So that's on the inside of the exponential function. So we're going to take the derivative of y times the derivative of the outside. Well, remember the derivative of e to the x is e to the x. It doesn't change. The derivative of e to the x is e to the x. So the derivative of e to the y is e to the y, except we had to do the chain rule here. Okay, so that's still e to the y. All right, well, how do we deal with this? Okay, so we have 1, 2, 3, and over here we have a fourth term. We need to get all the ones with dy dx on one side, and we're going to get the others on the other side. So maybe we'll subtract x squared dy dx and subtract 12y cubed dy dx. Do that from both sides, okay? So we're going to subtract x squared dy dx and subtract 12y cubed dy dx. Okay? And we end up with something like this. So we have 2xy, that's the thing that we left behind, equals e to the y times dy dx minus x squared dy dx minus 12y cubed dy dx. So we're going to factor out that dy dx, e to the y minus x squared minus 12y cubed, factor out dy dx, and we have 2xy over here. Now remember our goal here, our goal is to find the derivative. We need to find dy dx, so we're almost there. So we're going to divide this thing here. We're going to divide this whole mess and put this over on the other side, all right? E to the y minus x squared. Some of these steps once you got this down, you don't need to write down all these little steps that I'm doing here. I'll write them down so you really see what's going on. Okay, but we end up with 2xy over e to the y minus x squared minus 12y cubed. And I'm just going to flip sides around here, dy dx. There it is. So we found the derivative. It's in terms of x and y, but that's okay. The directions in it say that, but we always, when we do implicit, we're going to find these derivative in terms of x and y. Okay, let me clean that up a little bit. That's a y. Okay? All right, so that is called implicit. So there's a quick review of some of our main derivative rules. Thanks a lot.